That's James's salad of today. And I put it in layers so that you can see what I put in it. So the Saskatoons that we picked last year, and I thawed out from the freezer. And then some of those sweet peppers with chives from my garden, and little tomatoes, celery, spinach, and the wild rice. And it's pretty expensive. You buy a package like this, 250 grams for $6, but it's worth it. So I'm having it in a bowl because I am a very messy eater, and I'm gonna put some dehydrated parsley, which I would never buy this product, but it was given to me. I'm very thankful, and so I'll talk about that. And it's not that the product itself is bad or anything, and it's just that it's so easy to grow your own parsley, and you plant it once.
Around here it grows like a weed.
Yeah.
I can grow it like a weed.
So that's what I did. So I've tried a number of things to try to teach James how to garden on his own, and the first thing was parsley that I put in, because
it's going to be the last. It's going to be the last thing, because it just grows a volunteer crop, you know.
Yeah. So another thing that if you're a first-time gardener, zucchini, really good.
I've got some zucchinis going. And we've had a lot of rain.
We'll see how it will go.
I think they take a fair amount of water, because the whole thing is they're trying to stash a lot of water in a gourd type of thing.
Yeah.
So not really a gourd, but something like it.
Yeah. This was given to me back when we were going to the food bank, and I haven't used it because
it's been a long time now.
I know I haven't had a need for it, but I am thankful for it, and we'll use it today because we were going to go to James's house so I could do some yard work for him, but we'll do that tomorrow, and so I don't know what the parsley's like. I'm sure it's fine.
Oh, everything is fine, including the weeds.
Since I don't have it right now, I'm going to put some from here onto our meal. So I'm just going to put that right on top of the wild rice, and James can mix that in when he wants to, because the rice is still warm, and it'll kind of moisten that up. So if you mix that in, whatever. But the thing is I used to, when I first started cooking, when I was on my own, I'd buy these little jars of things, and then I realized if you cook, this is not enough. There's so little product in here that it just doesn't last if you make food for yourself. And plus, dehydrated parsley, just grow it yourself. Parsley is so easy to grow.
And how do you dehydrate it? Like put it in an oven or something like that? Or in a variety of different ways? You
could put it in a food dehydrator. Okay. But like just wash it, chop it up, and put it in if you want to. But what I do, if I dehydrate things, I don't dehydrate parsley. I don't bother. I just eat parsley when it's growing.
Yeah, put it on fresh. Why not?
Yeah.
You'll get more goodies out of it, I'm sure.
So, but if I wanted to, I'd just put it on sheets in my oven without the heat on, because I have a gas oven and it dries things.
It throws off quite a bit of heat just with a pilot light.
So I don't need to do anything with that. But so our salads are the same, but oh, there goes the book. We'll never see that one again. But his is in layers, so you can see. Now the rice, what I did was cook it with some of my cherry wine, and since James was making a joke about parsley, sage, rosemary, and thyme, I cooked it with some sage, rosemary, and thyme, and then I just put the parsley on top. So,
it's pretty impressive the way you put that dish together, let me tell you.
But,
and you know, like sometimes I think people think salads are a fast fix or something like that. I know Pauline was working on this for a long time.
And normally this is not how I would make this salad exactly. What I would do instead is I'd put some walnuts there, and I would not put those tomatoes there. The celery's okay in it, but beets are good in it too. So if you roast some beets and chop that up and put there, instead. That's good. But I don't know how those tomatoes will work out. I'm just going to eat the tomatoes first. That's why I put them on the top here, and then mix the rest in. And usually I don't put chives, because chives is a summer sort of thing to put on salads, and usually I don't make this salad in the summer. Usually I make it later on, or well, maybe late summer, early fall or whatever. And I've put cherries on it instead of Saskatoons. That's good. But it's usually I make it in the fall, and so then I'm putting maybe some dried cherries on it that I've dried in the oven on the sheets, and instead of the Saskatoons, but I could do it with the Saskatoons in the fall too. Anyway, it's great salad for that. And usually I put instead of chives I put red onion, but that's pretty much the only difference. So I'm talking more about mosquitoes are so bad. I'm never going to be able to get artwork.
They're going after you like crazy. I think they realize I've got a heavy coat on and they're leaving me alone. But
it's fine. So
this one is an absolute pest.
I'm going to have a few mosquito bites, I think, and
you're going to have a lot.
Talk about
I'll try to notify
germs.
you when one lands so you can at least scare them off.
So this is part 2 of my talk about killer germs, and I'll say that I highly recommend reading this book. It's by Pete Moore, and he says BSc PhD. And I don't know what those are in. There's no information on the back and stuff. So I'll have to actually look up Pete Moore and see what he specializes in.
But what you're saying is...
he did the job.
It doesn't matter what your credentials are like, where you get them from.
Yeah, if you do the research.
So long as you actually do the job.
And he did. So, well, you judge for yourself. I'll read my notes and see what you think. So this is part 2. I'm on page 66 of the notes. If you're following along, the group of antibiotics that penicillin is in have a similar structure, a 4-membered beta-lactam ring. Penicillin has no effect on the Mycoplasma group of bacteria because these microbes don't have a cell wall. Polymyxin attacks cell membranes by binding to phospholipids. It makes the membrane leaky. They can be dangerous to patient cells, so are rarely used. Quinolones, such as malodixic acid, blocks topoisomerase, which prepares DNA to be copied. These antibiotics can also damage patient cells, so rarely used. Chemical reactions inside cells are enabled by enzymes. Some antibiotics fit into the active sites, so the enzymes won't ever function again. Isoniazide TB antibiotic is an example. Page 68. Triclosan is an antibacterial antifungal incorporated into bedding, socks, soaps, toothpaste. It comes from the same pedigree of chemicals as 2,4-D and 2,4,5-T, the major components of Agent Orange. Most antibiotics have at least some synthetic chemical step in their manufacturing. Simple compounds like penicillin are still harvested direct from fermenting vats. Page 69. In 1949, the U.S. produced over 72 tons of penicillin and streptomycin a year. By 1954, this had risen to 200 tons and at year 2000, 200,000 tons a year. Page 70, only 100 years after, this is a quote, only 100 years after we realized that microorganisms caused infectious diseases, and just 50 years after we found a terrific way of fighting them, the bugs are biting back. 71. In 1947, Fleming warned the world about self-medication. Using too small of doses educates the microbes about penicillin, so the resistant strains are bred. In many countries, antibiotics can still be bought over the counter. Just a couple years after penicillin became available, one London hospital found 14% of Staphylococcus infections were resistant to penicillin. That's page 72. By 1950, this had risen to 60%. Neisseria gonorrhea became resistant to penicillin in the mid-70s because Filipino brothel women took it regularly to ward off disease. And I made a note, among the blind, the one-eyed man is king. Apparently that was Gerard Didier Erasmus, 1465 to 1536, who said that. I didn't know that. I just thought it was a Tom Waits thing. 74. Plasmids are small loops of DNA that sit inside bacteria separate from main chromosome. Plasmids can slip out of the bacterium, move to another when two bacteria are close together. A tube forms between the two. Like sperm moving through penis, the plasmid travels through the tube from one bacteria to the other. Cool, hey? A plasmid may give the bacterium a way to build protein that sticks to cells of human gut lining. Another may help resist severe changes in temperature. Another may give the ability to use a particular food source or live without oxygen. Wild, hey?
So plasmids are smaller than bacteria?
Yeah.
I don't see why they can't think of those as being living. You know what I'm saying?
Yeah. So there's a funny history of medicine on page 77. I'll show you because
I've been looking at plasmids for about a year now.
That's it. Funny, hey? So, I just wanted to show you that because I thought it was cute. I don't want to have to read it. In 1996, WHO report, too few new drugs are being developed to replace those that have lost their effectiveness. How microbes have learnt to evade treatment. 1. Blocking entry. 2. Inactivating the agent. 3. Pumping out. 4. Altering the cellular target so that the antibiotic can't attack it. 5. Developing a new biochemical pathway. 1998, paper by Laura McMurray. Tufts University of Medicine, Boston, found that triclosan keeps bacterium from building fatty parts of their cell membrane, similar to antibiotics, so it could cause resistance. Page 91. Globally, half of the antibiotics manufactured are fed to animals. And you'd want to look into that. No,
it's a little bit higher.
You'd want to look into that because this like I was saying, this book was published quite a while ago. So at that time, that was probably accurate. It's a multi-billion-dollar industry, and manufacturers
what would you guess
are reluctant.
It is 2/3? Sorry for interrupting.
Just look it up.
That's I think
manufacturers
what
are reluctant to see the market taken away. Page 92. A cow can weigh 10 times as much as a human and will need 10 times the dose. A typical human bowel movement throws out 100 million bacteria. Cows produce up to 500 times the volume of feces as humans do. So do the math. Some intensive agriculture systems are so poor or stressful that disease is highly likely if preventative medicines aren't given. Also, at increased therapeutic dose. American pig producers medicate piglets to remove them from their mums at 2 weeks old. Medicated early weaning. That's what it's called. This way the sow is back in production faster. The immune systems of piglets aren't fully mature yet, so they can't survive without the antibiotics. Page 93. Previously, before 2000 in the EU, the limit of antibiotic accumulation in farm soil was 7.5 grams per hectare, but it was raised to 75 grams, which could increase the likelihood of microbe resistance development in the soil. In 1997,
and in runoff, maybe.
The WHO set out a press release. Antibiotic use in food-producing animals must be curtailed to prevent increased resistance in humans. Resistant strains of Salmonella, Campylobacter, Enterococci, and E. coli have been transmitted from animals to humans. Page 94. In Europe, there is now a ban on feeding any antibiotic currently used in medicine to promote growth in animals. Page 97. German study. Pigs fed growth-promoting levels of streptotricin? I don't know. Had resistant bacteria within 6 months. Within 2 years, resistant bacteria were found in 1/6 of farm workers' E. coli samples. It also showed up in people who live nearby.
Suspected.
Also in 1% of those nearby with urine infections. 103. Spanish flu autopsies. Swollen, wet lungs with lots of thin, bloody fluid. Air pockets full of fluid. Up throat, froth. Bacteria took advantage of low oxygen environment and bred. Blue color started at ears and spread to face. When people died, the lung fluid often flooded out and drenched sheets. First wave was mild. First case, March 4th, 1918, in Camp Fuston in Kansas. In 1 week, 100 sick. At weekend, 500 very ill and 48 dead. Page 104, infected 8 million Spanish. In months, it swept the world and killed 20 million people. Others say it was 40 million people that it killed. 2 times the number killed in the war. 1918.
I think it's important to, usually with stats like that, is amp them down.
Yeah, so the 20 million.
I've seen what's happened, like with the casualties in Dresden and stuff, like firebombing of Dresden, and it's 10 times what the actual figure was.
1918, Sacramento people ordered to wear masks in public. Violators were fined $5 to $100 or 30 days in jail. By summer of 1920, it was gone, and no one knew where or why. Influenza A is a globe-shaped particle, 100 nanometers in diameter. Its cell membrane wrap came from the outer surface of the host cell that built it. Bilipid membrane is studded with 2 types of protein, which are spiked, hemagglutinin and neuraminidase. So the neuraminidase help them escape, and the hemagglutinin help the virus get into the host cell. 12 types of hemagglutinin, H1, H2, H3, blah, blah, blah. 9 neuraminases, N1 and N2 are in the human viruses. 108, when a virus approaches a cell, the hemagglutinins bind to carbs that stick out from the cell surface like jigsaw pieces. The cell envelops the virus, holding it inside a bubble membrane. The fluid in the bubble is acidic, which causes the virus to change shape. The bubble bursts, and the viral RNA is released into the cell. New copies are made, grouped together, and moved to the cell membrane where they're wrapped inside. This buds off and leaves to infect another cell. The Spanish flu was a type of H1N1.
Wow, I didn't know that.
Pigs, I knew it. Pigs are a good intermediate for many viruses.
No kidding.
Page 112, they're biologically similar to humans and act as a bridge between humans and others like birds. Chinese farming practices provide an ideal place for viruses. Chickens alongside fish farms with ducks swimming in the ponds, pig manure used as fish food, and the farmer lives in the middle of everything. Page 113, virus moves inside host cells. RNA replicates and makes proteins the cells have never seen. Cell takes samples of the proteins, chops it up, dumps it out of the cell for the white blood cells to check it out. It takes time to set up antibodies. Page 114. Page 116, we now make vaccines with either weakened versions of the disease agent or fragments of the agent's protein shell. Hen's eggs are great little incubators for viruses. They're sterile inside, have a lump of fast-growing cells, embryo, and lots of nutrients. Scientists working to develop a virus that looks identical to the chicken flu virus but will grow on eggs. Vaccines not as good as the real thing, but some protection. Page 123. AIDS virus moves in body fluids. HIV has been isolated from lymphocytes in peripheral blood, cell-free plasma, semen, cervical secretions, cerebrospinal fluids, tears, saliva, urine, and breast milk. HIV is spherical and 0.1 microns in diameter with 72 spikes of glycoproteins, GP120 and GP42. Inside the spherical coat is a cone-shaped core or capsid which contains genetic information. HIV is an RNA virus, genes stored in duplicate on 2, virtually, I made note of virtually, identical strands of RNA. On the 2 thread-like molecules, the virus stores info to build 2 structural proteins, 3 enzymes, and 6 other proteins that regulate the virus's replication. HIV favors T helper cells, white blood cell type. Their surface has CD4 studs that lock onto HIV's GP120s. Any T helper cell that swallows a virus thinks it did a great job, but inside the virus doesn't die. It reverse transcriptase copies RNA to DNA, which enters the cell's nucleus and becomes spliced into one of the chromosomes. Reverse transcriptase is packed along with RNA in the capsid. In the T helper cell, this enzyme takes the RNA and builds DNA, a provirus, moves from cytoplasm, page 125, to cell nucleus and is incorporated into chromosomes. This is the reverse of what normally happens. Animal cells only have enzymes that allow the nucleus-contained DNA to be transcribed into RNA, and this RNA travels from nucleus to cytoplasm. The presence of this enzyme is the origin of the, I don't know, I put name retrovirus. I do not think that's right. It may lay dormant in host cell DNA. Something triggers the provirus into action, but that's poorly understood. Page 126, the T helper cells infected with HIV is small, too small to account for the level of T cell loss. One theory, infected T cells are spotted and destroyed by the immune system. New cells replacing old until body system for producing them is exhausted, so then the T cell numbers decline. But why does it take over a decade for this decline? Virus depletes immune cells and damages lymph nodes. If germ cells in the testes or ovaries become infected, retrovirus may be passed down the generations. Some retroviruses have been present in certain species so long that they are seen as part of the species genome. Page 127. When proviral DNA is transcribed back to RNA, lots of RNA is made. Viral swarm, mistakes occur, resilience. Reverse transcriptase has no error correcting function. Most other systems have exon nuclease. Page 129, an editing enzyme that checks codes and edits mistakes. Antigenic shift, retroviral sex, causes a lot of variation. Antigenic shift causes pandemics due to no immunity of hosts. Page 130. Gaten Dugas, a Canadian air steward, was branded with the title Patient Zero. He was gay, claimed he had sexual relations with 250 men a year. He had a total of 2,500 sexual partners and refused to curb his sexual behavior to prevent the spread of AIDS. His quote, "Someone gave this thing to me, I'm not going to give up sex."
Wow.
Page 131.
What did they do with him?
Well, he died. Page 131. Free sex gave HIV a free ride. The social disorder in Africa helped fuel the fire. Men traveled hundreds of miles to work on farms and mines and seldom went back to visit their families. They frequented brothels and then brought the disease back to their villages.
So what they would do at the mine places is they have dormitories for the men. So
yeah.
Very bad system.
Mm-hmm. So anyway, the receptive partner of the sexual act is most at risk. Female to male transmission increases if she's on her period. And I didn't know that. But page 1992, FDA study. No, page 132, 1992 FDA study. HIV could penetrate condoms. I didn't know that. I guess they did a study. The FDA took glass beads of the same size as approximately to a virus particle, and they found that it got through the condoms.
Well, there you go.
Yeah. So the CDC said the FDA study was flawed and that condoms give good protection as long as they aren't damaged or old. But what do you do, right? This makes me think, nope, condoms, that's not a safe way to go. I mean, it's better than nothing, one would assume, but it's
just show a little bit.
Get tested and don't have partners that you don't know well enough to know whether they're gonna. Anyway,
show a little bit of restraint.
HIV came from African apes. HIV-2 from the West African sooty mangabe monkey, and HIV-1 from Pan troglodytes, a subspecies of chimpanzee. So that's funny, troglodytes. So that's where that.
Cave dwellers.
They both carry SIV. These animals don't get ill from it. I'm putting question marks. I'm presuming they still get ill. Or wow, we should all have that. Page 134. Some theorize that the explosion of HIV came from infected batches of polio vaccine given to 1 million people in the former Belgian Congo and regions of Rwanda, Burundi between February 1957 and June 1960, causing the 1970s pandemic.
Could have been, that would have been an early form of the polio.
Yeah. Well, I wrote a little bit about, or talked a little bit about that from another book that I read before. Mm. So in a book, The River by Edward Hooper, he says, Hilary Kaprowski of the Winster Institute in Philadelphia developed the polio vaccine by growing viruses on kidneys taken from African chimpanzees, but Kaprowski denies any link between the vaccine and the chimps. So who knows?
Well,
Using cells from other animals is dangerous. There are retroviruses within their genome that they live with, but in a new environment, they could break out with unforeseen consequences. Babraham, near Cambridge, England, genetically modifying pigs so organs will avoid detection by the human immune system. Retroviruses could move from pigs to human. Page 141. Dengue fever starts with flu-like symptoms. It seldom causes serious damage. Dengue hemorrhagic fever starts similarly to that one, but the liver enlarges and the person's temperature shoots up to 40 to 41 degrees Celsius and stays there for 2 to 3 days. Either the symptoms slowly go away or the patient goes into shock and dies within a day of that. So Ebola comes in 5 types, each named after the place where it was identified. Ebola Zaire, Ebola Sudan, Ebola Reston, Ebola Thai, and Ebola Ivory Coast. Ebola Reston can transmit from victim to victim through air. Zaire kills 9 out of 10 infected people. Sudan only kills 6 out of 10.
How many out of 10?
6 out of 10 for Sudan.
That's pretty high.
It is. Ebola likes to live in cells that build small blood vessels. When the new virus bursts out after replication, the cells are destroyed. Eventually, blood vessels leak, so red eyes, etc. Page 145. Lassa Nigeria fever virus passed through blood, urine, throat secretions coughed into the air from a rodent, apparently. That's where that one came from. And that's page 145. Lassa you can breathe it in from dust contaminated with dried urine from infected rodents. So that's terrible.
Sounds like hantavirus.
I know. That's what I was thinking.
I always worry them
Only,
about dust
I mean,
with COVID.
this sounds worse.
Mm-hmm.
Page 152. English bacteriologist Edward Thorpe, 1915. Phages. Phages exist wherever bacteria exist. Page 153. A large polyhedron sits on top of a short stalk, and in the bottom of the stalk are 6 spindly legs. I won't have enough to finish all this, so I'll just do what I can. Phages can only infect bacteria. They lock the ends of their legs to specific cell surface receptors. They compact their stalk, which drives a needle-like tube through the bacterial wall. The DNA contained in the polyhedral head passes into the bacterium. They replicate, burst out of the growing bacteria cell, and it's destroyed. Phages are specific to bacteria. Growing phages on batches of bacteria for manufacturing purposes might be dangerous. Page 155. Phages are not living organisms, they are viruses.
Depends on how you define.
Defined currently. Page 156, virtually. And I will start off from there later on. So that's that.